Hey, good morning, everyone. So, this is going to be our Aerospace 2, Chapter 3 quiz review. Um, in this section, we talked about aerodynamics and forces of flight. So, if you're ready, we're going to go ahead and get started. So, a big individual we talked about was Sir Isaac Newton. And Sir Isaac Newton is famous for writing laws of physics. So, when examining Isaac Newton, we should be able to identify that his three laws of motion, it applies to everything on Earth. It can apply to airplanes, helicopters, cars, bicycles, even yourself. We will go more about the specifics of the law to come. So the next thing I want to talk about is aerodynamic forces. The forces that generally apply to an aircraft are the four fundamental forces of flight, which are lift, weight, thrust, and drag. Now, as an aircraft flies through the air, there are aerodynamic forces that are applied to that aircraft because of the passage through the air and the air moving over the wings. So fundamentally, the creation of lift is actually a product of the interaction between the physical structure of the aircraft and the flow of air around that structure, in this case being wings. So we spoke of three different laws. The first law that we spoke of is the law of net force. And what that allows us to do is it allows us to break apart the forces that are acting upon an object. So if I have an airplane in flight, like we said we have, lift going up, weight going down, thrust pushing us forward through the air, and drag pulling us back and slowing us down. Utilizing the law of net force allows us to take the net values between force and drag. So that's how that is going to work. I apologize, I am reading a computer and I'm trying to get ahead. I apologize. In this chapter, we also determined what the main goal of an aerospace engineer, what his focus is to do. And the main goal of an aerospace engineer is to be able to reduce drag and generate lift. Since drag pulls an aircraft backwards, that actually ends up costing companies tons of money every single year. And as aerospace science advances, their goal is to reduce the amount of drag, so aircraft will be more efficient and use less fuel, thus generating more money. So the next thing we're going to talk about is we're going to focus on certain types of forces. I went over them a little bit previously, but we're going to go over it again. So thrust is going to be the force that propels an aircraft forward. It is made by a rocket motor or an engine of some type. Lift is the force that is created by the wing that picks the aircraft up and allows it to fly through the air. Drag is the force that is created by friction and slowing the aircraft down. And weight is the force that is caused by the pull of Earth's gravity, pulling that aircraft back down to the surface. We also talked about some of the forces that act on the aircraft that are created by the aircraft. One of the forces we talked about is on takeoff, an aircraft's wings flowing through the air from the bottom of the wing wants to go to the top of the wing. As the aircraft is moving forward, though, this creates a rotating cylindrical mass of air that we call a vortex. And those are prevalent on takeoff and landing of aircraft, and that is when people should be most cautious of them. The next thing we're going to talk about that we went over two major things. We went over the conservation of momentum and the conservation of energy. The conservation of energy is explained by Daniel Bernoulli. And the Bernoulli equation explained how lift worked. And then we also talked about the conservation of momentum explained by the Coanda effect. And the Coanda effect is as the laminar airflow, which is the airflow closest to the wing, goes over the wing, that laminar airflow actually can have effect on the surrounding air, thus helping it create more lift. That is the Coanda effect. So energy conservation is explained by Daniel Bernoulli, and the Coanda effect explains the conservation of momentum. So as we examined Newton's laws, we should also understand that there are multiple forces acting on an object. Like we said, of an airplane, we have thrust, lift, weight, and drag. That is in completely unaccelerated, stabilized flight. But if we have, say, a car on the ground, it is still being acted upon by the weight pulling it towards the surface, thrust, which is pushing it forward, friction from the air, which we call drag. But even if that car is not moving, if it is completely stopped and it is completely at rest, you need to be considerate, because rest is a force just like any other force. So while the car is moving, it has a lot of kinetic energy and no potential energy. But while a car is at rest, it has potential energy to go and zero kinetic energy. So rest is a force just like acceleration or thrust or drag and friction. I hope this helps you guys out. I hope to see you do really well. Have a good day.